Good morning, amazing people. Welcome to the second day of DevOps Pro conference. Sunny outside, amazing mood. This music on the background of the countdown really puts me in a very positive mood. So thank you to organizers for this. My name is Elena Sobolevska. I'm coming from Accenture Baltics. And here today I am hosting the whole one. So we'll see you around. And here this morning, our first amazing speaker is Wolfgang Ofner. Good morning, Wolfgang. How are you today?
Good morning. I'm good, thanks.
Wolfgang is coming from Austria and recently moved to Canada from Australia, which is, a crazy geographic. And what about the weather? How do you feel after crazy hot to, North climate?
It was a bit cold in the beginning, but yeah, Australia is really hot, so I enjoy the Canadian weather so far.
I see you sitting in a hoodie. Probably that wouldn't be possible in Australia in this time of year.
Oh yeah, in Australia it's always flip-flops and shorts, so it's nice to wear a hoodie again.
I understand you totally. How old were you when you started IT?
I really like computers all the time, but professionally, I think I started studying with 23. So this is when my programming career started. But yeah, I was already playing around with computer when I was around 8 years old and trying to install software and just get to know how everything works.
So it's a natural talent and kind of interest was born with the computers inside your head.
Yeah, exactly. I was always curious how technology works, how to break stuff, how to get stuff working.
Yeah, and DevOps actually is about fixing stuff all the time. So yeah, you're trained for that since your childhood. I really loved how you're using Black Friday to kind of have this feeling on scaling. When I talk about Kubernetes, I use in Latvia our tax platform, which actually on 1st of May, we have to go in to see if government owes us any taxes. And it always, it breaks. You have to spend hours to try and get in. And you're always like, Kubernetes. And with your level up, your Kubernetes scaling with KEDA, for sure, our government platform could be more efficient. So let's see how it actually works, what we can learn from you, and I can send this video to our tax guys so they are better next year.
Yeah, maybe you can tell them to hire me. I'm here to help if they need me.
Oh, amazing! We have a business already. So the stage is yours. Thank you. Listening with all my ears open.
Yeah, thank you for the introduction. Hello, good morning, everyone, to my session, Level Up Your Kubernetes Scaling with KEDA. Before we start, a couple sentences about myself. My name is Wolfgang Ofner. As you have already heard, I recently moved to Toronto in Canada, and I'm working as a freelance cloud architect. My focus is on Azure, and especially on Kubernetes and DevOps, and as well as on .NET. If you want to get in touch with me, send me a message on LinkedIn, on Twitter, or find me on my blog. Today I want to give a brief history of the architecture and software projects. Then I want to give an introduction to KEDA, and then I'm going to show you a practical example how we can use KEDA to scale our application according to messages in an Azure Service Bus, and also how to scale an Azure DevOps agent that's running in Kubernetes with KEDA. In the end, I'm going to give you my opinion on KEDA, and then we have some time for Q&A. So if you go back many years, we had a very simple software architecture. Often we had a server and a couple of clients. The internet was not very popular back then, so we had only a handful of clients. We had no redundancy, no high availability. Everything was simple, but if something broke, it broke for everyone. But since we only had a couple of clients, this was okay back in the days. Then the internet got more popular, online shopping, other websites, and so we needed more and more resources to run our software. And so we found out that this works great with load balancing. So we could install a couple virtual machines, added a load balancer, and then use the virtual machines. So if one VM died, we had others that are still running. The problem back then was it was really expensive to buy the hardware. You had to install it, you had to update it, take care of it, and it was better, but it was still quite a lot of work and expensive. Then with the rise of the cloud provider, we were able to add new hardware automatically. We didn't have to buy it. We could use what we needed and only pay for that, so we didn't waste any money. And the scaling was based on CPU or RAM usage mostly. This was fine back then. That's already more than 10 years ago. But nowadays, if we look at an example architecture, our software is getting more and more complicated. I don't even want to talk about the details here. It's just a couple examples. For example, we have here a service bus, so we send some messages around. We have here 2 different Kubernetes clusters. Then we have some databases, another database, caching. We have Java applications, we have microservices. So it's really complicated. So scaling based on CPU and RAM usage didn't cut it anymore. We have so many more dependencies, resources we have to use. So we had to find a new way to run our software efficiently. So one way to run our software is Kubernetes. Kubernetes is an awesome tool that helps you to run software, to scale it. And the way Kubernetes scales their software or the application inside is the horizontal pod autoscaler, or short, the HPA. The HPA scales the applications based on CPU or RAM usage. But as I said, the architecture gets more and more complicated. It's really complex. So we have to scale based on dependencies. This could be a message in a service bus, an event in a database, or from a stream. And so the horizontal pod autoscaler is not enough for that. Just a couple more sentences about the HPA. The horizontal pod autoscaler scales deployments or stateful sets, and it does this by adding or removing pods. If you don't know Kubernetes, a pod is the smallest unit, and simplified, you can think of it as a container. And as I said, we can scale based on CPU and RAM usage, but we can also write our own custom metrics. So for example, we could query the Kubernetes API to get some more information. We could query Prometheus, and we can scale, for example, based on requests per second if we query these APIs. But for me as a developer, I'm not really interested in learning how to send messages to the Kubernetes API, to scrape data from Prometheus. So that's not really feasible. And also, as an operations person, you might know of this, but it's a lot of work to write the queries, put it in the application. So that's not a great solution. And here you can see the configuration of a horizontal pod autoscaler. So the type is horizontal pod autoscaler, and then we configure it. For example, here we have the maximum replicas. So the maximum amount of instances is set to 10. The minimum is set to 1. And we aim for a CPU utilization of 50%. So if our CPU utilization is, for example, 80%, the horizontal pod autoscaler automatically adds new pods until it reaches the maximum of 10. And if the CPU utilization is low, for example, 20%, the HPA removes pods and scales down the application. Then here at the bottom, we have the target of our scaling. So in this kind, it's an application that's called custom API. And on the middle and the right, we have the scaling policies. For example, we have a scale down policy that says we want to scale pods, and we want to scale 4 pods at a time within a time frame of 60 seconds. So if a scale down is executed, the horizontal pod autoscaler removes 4 pods and then waits 60 seconds. And if the CPU utilization is still too low, it removes another 4 pods. But we can do the same with percentage. So we can say we want to remove 10% of our running pods. And on the right side here, we can see the scale up. It's the same. So you can add, for example, 5 pods at a time, wait a bit, and then evaluate the situation again. The problem is the horizontal pod autoscaler is great. It's built in Kubernetes, but it has a couple of limitations. We already have heard tax season can be a problem, but in my experience, or what I've experienced in the past, is Black Friday is also a big problem. If you have an online shop, you have a steady business over the year, and then Black Friday is the biggest day, and sometimes you have traffic that's 10 times or even more higher than a usual day. So back in the day, you had to buy hardware to survive this day. But then 364 days of the year, this hardware was basically not used because you didn't have the traffic. So it was very inefficient and expensive. And nowadays we can scale dynamically, especially with the cloud. But the problem is if we scale based on our CPU and RAM usage, we might not scale with the right events or dependencies. For example, in an online shop, if you place an order, this order is often put into a queue, and then this queue is processed. You might notice from Amazon, like when you click on order, it says within a couple seconds your order has been placed, and then you get an email like 15 minutes later, your order is confirmed or something went wrong. For example, your credit card got declined. This happens because it took 15 minutes to process all the orders in the queue. And if you have many customers on our Black Friday sale and they put thousands or tens of thousands of orders into our queue and we can't process them fast enough, it will take days or maybe weeks to process them, and our customers won't be happy at all. And with the horizontal pod autoscaler, we can't scale based on CPU or RAM because messages in a queue is a different value. So we don't have an option to scale in this example. And this is where KEDA, the Kubernetes event-driven autoscaling, comes in handy. So KEDA is an open source project, so you can check it out on GitHub. You can commit code. There's also, I think, bi-weekly meetings which you can join. It's a Kubernetes, it's a CNCF project. That's a cloud-native computing foundation. And it's maintained by big companies such as Microsoft or Red Hat. KEDA has right now 61 built-in scaler, and every couple of weeks a new bunch of scalers coming into the code. And this scaler help you to scale based on external events or technologies. And that's a whole bunch of different technologies. For example, with Azure, we have Azure Monitor, Service Bus, but we also have Elasticsearch. We have databases such as MongoDB. You can analyze streams such as Kafka or Redis streams. So it's every kind of technology you could think of. And the use cases of KEDA, as already said, you can scale according to external events. For example, if you have a message in our service bus, you can scale according to that, but you can also scale to zero. And scaling to zero is a great tool to use your resources and also to bring a serverless architecture to your data center. Serverless technology such as Azure Functions or AWS Lambda, they are not running, and only when they're needed they scale up. So they scale from 0 to 1 or more instances, execute the workload, and when they're done, they shut down or scale to 0. An example is if you go back to our online shop. During the day, we have the customers on our online shop, so we want to have the best performance for the shop. So we use all the resources on the shop, on the UI, and during the night we have way less customers. So we can do background tasks, for example, creating shipping labels, calculating loyalty points, and so on. And in the morning, when all the calculations are done, we scale these services to 0 and use all our resources for the online shop again. Then the installation of KEDA, it's quite simple. You can install it via Helm chart, and the only requirement is that you install it in the namespace KEDA. So in Kubernetes, first you create the namespace KEDA, then you can add the Helm chart, you can update it to make sure you have the newest version, and then you install it. It takes a couple minutes, and then you have 2 pods running. So you have the operator and the matrix API server. And these are the 2 components of KEDA. The operator, which is also sometimes called agent, is responsible to scale to 0 and from 0 to 1. And the matrix server sends matrix information to the horizontal pod autoscaler, and then the horizontal pod autoscaler does the scaling. And since we use components that are already in Kubernetes, it's quite easy to add KEDA to an existing application because you're not changing anything. You're just instructing the HPA to scale up or scale down your application. And here we can see how this works. So for example, here we have the matrix adapter, and it sends information to the horizontal pod autoscaler, and then the horizontal pod autoscaler scales the workload. Or if you want to scale to 0, or from 0 to 1, we go this way, and the agent does the scaling. And to scale our application, we need 2 custom resources. First, the scaled object that's configuring the whole scaling process, and then the trigger authentication, which configures the authentication. For example, it will contain the connection string to a service bus or to a database so that the scaler can check what's going on inside this object. So here we have the scaled object, sort of kind scaled object. Then we have here target. So the application we want to scale is so-called a KEDA demo API, and then we can configure it here. So we can say the minimum replica count is 0. So this allows us to scale to 0. Then the maximum is 10. The polling interval means KEDA checks every 30 seconds if something has changed, if it needs to scale. And after scaling event, it waits 30 seconds as a cooldown. I configured 30 seconds because it's easier for a demo, but the default values are 5 minutes. And you shouldn't scale up and down every couple seconds. So 5 minutes would be a good value. And then we have here a trigger. So we have the type Azure Service Bus. This means we scale based on an Azure Service Bus. Then we have a queue. So the queue we want to scale off is called KEDA demo, and the length is configured as 5. This is a bit confusing because it means we scale if you have more than 5 messages. So if you have 5 messages, we don't scale. If you have 6, we scale up our application. And here we have a reference to the authentication, and it's called Trigger Authentication KEDA Demo API. And here we have the trigger authentication, and it has the name we just referenced in the scaled object. Again, Trigger Authentication KEDA Demo API, and this has a reference to a Kubernetes secret. So the name of the secret is KEDA Demo API connection strings. And inside this secret, we have a key that's Azure Service Bus _ connection string. And this secret contains the connection string of the Azure Service Bus. So if you go to the Azure CLI, we can say kubectl get secrets. Then we get a list of all our secrets. And then we can say kubectl describe secret and paste the name of the secret we want to inspect. And there on the bottom, we can see the key we referenced before. And if you prefer using a dashboard, you can do the same. You go to your secrets, find the secret with the name you're looking for, and inside you find the key and the value as a base 64 encoded string. So now I want to show you how we can scale our application based on messages in an Azure Service Bus queue. So we're gonna scale to 0, and we're also gonna scale to 1. So let's go to the Azure portal. And right now we can see we have, we have 0 messages in our queue. And if you go to a dashboard, we can see we have here 1 container, but as you can see, this is not a KEDA container. This is just for HTTPS for SL certificates. So our application is scaled to 0. So now no pod is running at the moment. And if we send now a message to the service bus, then KEDA will see within the next 30 seconds that we have a message in the queue, and we will scale from 0 to 1. So if you go back to the dashboard, there you can see the pod already has been started. So you can see this pod is new. It's a KEDA demo API pod, and it's already running. So our application is running and can process the message in the queue. And if you say we have many messages at the same time because we just send out a newsletter or we have a great sale and we get many messages at the same time, we can also simulate this. And we say we have 200 messages in our queue because we couldn't process them fast enough with the 1 instance we have running at the moment. Then KEDA will see that we have more than the 5 messages we configured before, and will scale up more instances. So if you go back, there you can see we already have 5 pods running. And if you wait a bit longer, KEDA sees that there's still so many messages, and now we have even more pods running. So you can see here there's different times. A couple started 16 seconds ago, and more started 31 seconds ago. And now we have all 10 instances running, so that's the maximum we configured. Even we still have more than enough messages in our queue, KEDA is not starting more pods because that's the maximum we configured. And you can also see here on the right that some pods are running and some are pending. I'm gonna get back to that in a couple of minutes. And if we say now all our messages have been processed, so we can delete them. So we have 0 messages in our queue again. And if we go back to our dashboard, then it takes a couple seconds and KEDA is already terminating all our pods. So if you check here, there's 1 pod running, but that's again from the SL certificate, and our application has been scaled back to 0. So we don't need any resources because there's nothing to process at the moment. So if you're interested how this works, I added all the screenshots in the presentation so you can take a look at them later. I'm just gonna skip over this because that's everything I just showed you. And another important thing is scale to zero only makes sense for applications that process something. For example, if you have a website and you scale this website to zero, no customer can access the website and will get an error message, like here, the 503. So if you have a website, scale to 1. And if you have services, for example, processing orders, then you can scale to 0. And what's also interesting, especially for operating, you want to know what's going on inside your cluster. And for that, KEDA, especially the KEDA operator, writes logs of the scaling events. So if you look at the log messages, you can see here the target. You can see the KEDA demo API has been scaled. Then we can see the original replica count, that's 6. And the new replica count is 0. So we know the KEDA demo API application has been scaled from 6 to 0. And then in the next one, we can see it's again the KEDA demo API has been scaled from 0 to 1. So we know a scale up event has happened, or scale out. And with very great technology, there are some limitations. The biggest one is probably if the scaler for the technology you want to use is not available. KEDA already has 61 scaler. It should be able to use most of the technologies out there, but sometimes use something that's not available right now. So you can either write the scaler yourself and create a pull request, or you have to wait until KEDA provides a scaler for the technology you're using. And the second problem can be that the cluster runs out of resources. That's not specific a KEDA problem, but if you scale up and down quite quickly and often, it can become a problem. And if you go back, here you can see again, a couple of pods are running, some are not running. That's the same what we have seen before. And if you check out one of the pods that's not running, for example, the first one here, and look into events, we see an error message. It says insufficient CPU. This means our Kubernetes cluster doesn't have enough CPU to schedule the pod. That's exactly what we've seen before. So we wanted to run more pods than the cluster could handle, so we were not able to do that. If you're using Azure, you can use the Azure Cluster Autoscaler. This allows you to add automatically more nodes. This means computing power to your Kubernetes cluster. You will pay for it, but you can scale as much as you want, as long as you can afford it. So I would recommend, not only with KEDA, so with all technologies, define a replica limit that makes sense. Don't say I want 1,000 replicas because it's a great number. Think about what you're going to need and also test it out. If you do a load test and you see 20 instances enough, then use 20. You don't need 100 or 1,000. And also, as always, monitor what's going on inside your cluster, how often you scale, how many resources you use, so you know what's going on and you're not surprised when you suddenly scale. So we have a couple minutes left, and I also want to show you how you can run your own Azure DevOps agent that's running inside Kubernetes and scale with KEDA based on pipeline need. Since we only have a couple minutes left, I'm just going to show you a couple screenshots and explain how they work. And what I want to show is first how to prepare your Azure DevOps server, then how to build and run the Azure DevOps agent locally, so you can also test it locally. Then we're going to deploy it to Kubernetes, and then apply KEDA to scale based on the need. So the first thing you have to do is create a new personal access token. So you go to the settings of your Azure DevOps server, and there you can see personal access token. Then you say new token, and then you can define a name. how many days it's valid or when it expires, and then you give it the read and manage permission for the agent pools. Then you click on create, and then you can see the access token. What's very important is to copy this value, because this is the one and only time you see the actual token. If you press the X, don't copy it, you have to create a new token, because you will never get the value back. The next thing you have to do is create a new agent pool. Our agents are going to run inside this agent pool. So we go to the settings again, click on agent pool, and then on the top right, add pool. And here you can provide a name. And what's important is that you select as a pool type self-hosted. Then the next step you have to do is download the Docker file. I have a link to it later on. It's on my GitHub, or you can also download it from Microsoft. And also, this repository contains a file that's called start.sh. This file configures the DevOps agent. And what's very important is, if you save this file, to save it with LF end of file settings. That's Linux file settings. And if you save it on Windows, the application won't run, and you will get a weird error message. And it took me, I think, a whole afternoon to figure out what the problem was. So just think about it, save it as LF, and you won't have any problems. And here you can see the Docker file. Everything except the red parts are out of the box. So it configures everything that's needed to run the Azure DevOps agent. But you can also add the software you need. For example, I added here the wget command, and with this, I installed .NET 6 and .NET 7. This means my Azure DevOps agent is able to build .NET 6 and .NET 7 applications. So if you have Java, PHP, whatever application, you can just add everything that's needed and use your agent to build the application. And as you can see here on the bottom, this Docker file is going to start the start.sh file. So that's the reason why we're going to need it. Then you can build the image with a normal docker build command. And as you can see here, it took 376 seconds to build the image. When I did this, I had quite a slow internet connection. And it took so long because the image has, I think, 1.5 gigabyte. So it's quite big. And after you've built the image, you can start and run it. And to do that, you need your personal access token. You need the pool name you created before, and you need the URL to your Azure DevOps organization. So you can see here on the top, we say Docker run, and then we provide environment and variables. The URL to my Azure DevOps server, then the personal access token, then an agent name. This can be any agent name. I'm not very creative, so I just named it agent, and then you provide the pool name. Then you can see it's starting. It takes a couple seconds to start to connect to the server. And once the agent is running, you can run your own pipeline. And the most important thing is that as a pool, you select the name you created before. So I created an agent pool that's named KEDA, so I provide this name here. And as you can see, this pipeline is executing a script with nothing in it. So it's just to test that it's running. And when you execute this pipeline, you can see everything worked. And if you get to your command line where the agent is running, you can also see here it's listening. So it's waiting for jobs or pipelines to execute, and then it's running, it succeeded, and also it removed everything. So the agent shuts down. The next step is to push it to a container registry. I pushed it to Docker Hub. So if you want to use my image, you can just download it from Docker Hub in my repository, and it's called ADO Agent KEDA. So now that we have tested that it's running locally, we can start to prepare to run it inside our Kubernetes cluster. So first we have to create a secret in Kubernetes, and the secret contains our Azure DevOps personal access token. And we add the secret down here. And in Kubernetes, every secret is base 64 encoded. So encode the token you have and paste the value there. And as you can see, if you want to use my code, I've added a comment everywhere where you have to replace a value. So it should be quite easy to get started with the code. And besides the secret, we're also going to need a deployment. And this deployment is going to take care that our agent is running inside the Kubernetes cluster. So we provide the image name we have pushed to Docker Hub before, or to Azure Container Registry, wherever you want your images. Then you provide the name to your Azure DevOps server, and you provide the name to the pool, the agent pool you created before. To make it easier, I created a new namespace in Kubernetes. It's called ADO agent. Then I set the context to this agent, to this namespace, so I don't have to type the namespace at every command I execute. Then we deploy the YAML file containing the deployment and the secret, which we have just seen. And then I'm just going to wait for the pod to start. So you can see it took 88 seconds for the pod to start because the image is quite big. So it takes a bit for Azure to download it and start it. But the agent is running now. And if you go to our Azure DevOps server to agent pools, we can see that the agent is online and everything is fine. And what you do next is you disable this agent because this agent is needed so Azure DevOps can use KEDA agents. That's a limitation of Azure DevOps. It needs at least one agent inside the pool to be able to use the pool. So we have this one, we disable it because we're not going to need it. And what you can also do before you disable it, you could run the pipeline again and make sure that the agent is running. But this should work because it worked locally. But to be sure, you can run the pipeline again and then disable the agent. So next, we have to configure KEDA. So we create our scaled object. And there we provide basically the same values we had before. So we provide here the image of the Docker of the Azure DevOps agent. We provide the URL to our Azure DevOps server. We provide the name to the KEDA pool, to the Azure DevOps pool. And the only thing we also need is the ID of the pool. And you can get it if you execute this command. Just replace organization with the name of your organization, and there you will find all the pool IDs. The only thing you have to do is paste it as a string, not as a number. Then you can deploy this scaled object. And then I created a new pipeline, and it's again a very simple pipeline. So I still use the KEDA pool. And as you can see here, I have a couple jobs. In total, I think I have 5 jobs, and all these jobs are doing is sleep for 5 minutes, so I can see something is happening. And when I execute the pipeline now, I can see that KEDA is scaling the Azure DevOps agents, and we can see here that we have 5 agents running because I have 5 jobs in my pipeline. But if we go to the Azure DevOps pipeline, we can see that we have here 5 jobs, but only 2 of them are running. That's another limitation of Azure DevOps, because I only have licenses to run 2 parallel jobs at a time. So it doesn't matter that you self-host it, it's just a license problem. And KEDA doesn't know this. KEDA sees 5 jobs are running, so I have to start 5 agents, but Azure DevOps restricts me of running 5 jobs at the same time, so it only executes 2. And as already said, Azure DevOps has a couple limitations. For example, you need at least 1 agent inside the pool to be able to scale to 0. Otherwise, Azure DevOps can't use this pool to run pipelines. And as I said, you have to take care of your licensing. So if you only have 1 or 2 licenses, you can only run 1 or 2 jobs at the same time. And also KEDA has a couple limitations with Azure DevOps agents. For example, if you cancel a pipeline, KEDA doesn't recognize it and will just continue running the Azure DevOps pods. So they will run forever. And also, when pods are completed, they are not removed. So what you can do is have a job that's running, for example, once a day, and remove all these pods just to clean up your Kubernetes cluster. And also in Azure DevOps, in the pool, you will see a lot of offline agents because they're not removed after they shut down. So to finish up this presentation, my opinion about KEDA and if you can use KEDA in production or not. So Microsoft is using KEDA itself for various Azure services. The most prominent one is probably the Azure Container Apps. They are available for a bit more than a year now, I think, and Microsoft takes care of the scaling of your workloads there, and they use KEDA for this. And also, if you use Azure Arc and run Azure App Services inside your own Kubernetes cluster, the scaling will be based on KEDA. So in my opinion, if Microsoft is using it for Azure and they're confident, I don't see any reason why I shouldn't use it for my own projects. And also KEDA was first launched in November 2019. So it's already quite a couple of years old. And we're at version 2.10.1. And there are a couple of updates. There are updates every couple of weeks. And it also has more than 6,000 stars on GitHub. So it's quite popular. The team is great. So if you have any questions, you can post an issue, get an answer. And you can also join the, I think, bi-weekly meetings and listen to what the plans are and also can provide feedback. Then a couple of resources. So the first one is a GitHub link to a repository where you can see the demo, how KEDA works. And the second one is the repository about the Azure DevOps agent with KEDA. Then also links to KEDA and the GitHub page and the architecture of KEDA. And if you want to get the slides from today, you can scan this QR code, or you go on my GitHub page and find it in the presentation folder. And if you have any questions, feel free to reach out to me, LinkedIn, Twitter, or send me a message on my website. I'm happy to help if you have any questions. And with this, we're done with the presentation. So thank you, everyone. And if you have any questions, feel free to ask now or later.
Thank you very much, Wolfgang, for a very detailed presentation. It was very, very, full of details, so everyone could understand it. Thank you. We don't have any questions in the chat, and actually we have last 5 seconds, so thank you for perfect timing. You used all the time we had, so it's amazing. Thank you very much for coming to DevOps Pro Conference, and see you around in DevOps world. We always pop into each other there and here. Thank you.
Yeah, thank you for having me.
Bye.
Bye.
This is all we got. Remember the revolution in our minds. This is all we got.
Lock me out of this life institution. I am angry and high on illusions. Yes, I hate, but it's not a solution. Try my best, but I'm just a